So here we are looking at some scientific notation numbers. And remember, on your calculator, when you're seeing something like 5.76 E7, that means 5.76 times 10 to the 7th power. So that's how it would read in your calculator. Remember that E just means times 10, and then they're showing you the power of 10 here. So here we are looking at the distance to Mars from Earth. And again, it doesn't really look that big when you think about it. 3.58 times 10 to the 7 miles. How far is that? Well, in order for us to understand a little bit, and since we haven't worked with scientific notation numbers a great deal right now at this point, we want to think about that in terms of what does that look like to us. So here we go, practicing converting scientific notation numbers back into standard form. So here are two examples of scientific notation numbers and their standard notation values. So 3.4 times 10 to the 9th is going to be 3,400,000,000. And then we've got this very small number of 5.76 times 10 to the negative 8. And it's really important to understand that 10 to the negative 8 means 1 over 10 to the 8th, which is a tiny number, but it is not a negative number. So please, please, please remember that as we keep working through these. So our general structure is we are going to have, with standard notation, we're going to have values that are greater than 1, and the more numbers in front of the decimal, that's the tens place, and then we always have portions of 1 after that. So just think about our normal numbers that you've been working with, and that is what we're talking about when we talk about standard notation. So we are converting from standard notation, scientific notation, to standard notation. So here's what I like to do and how I like to look at it. I'm going to move that over here. So in this case, we have 3.562 times 10 to the power of 4. So what I like to do is I like to start off by taking my number, the 3.56. I take that 3.562 and I start adding some zeros to it because I know it's a bigger number than the 3.562 that I have. So I write some extra zeros at the end of my number, and now I look at where my decimal place is, and right here is the original spot of my decimal place. And because my power of 10 is 4, I'm going to move that decimal place 4 spots. Now think about this. This is a big number. So I'm going to make this 3 look bigger by moving it 4 spots. So I move it 1, 2, 3, 4. And this is where my new decimal place is going to be. Here's where it was started, but since I've taken the power of 10 away, now I just have the 3, 5, 6, 2, and you can put 0, 0 after that, depending on significant digits and things like that. We're not going to worry about that. So our 3.562 times 10 to the 4th is really 3,562. That is our standard form, and that is how we can write that in standard notation. If you like to place your commas in there, again, to help us understand that value, you can do that. Now, with really small numbers, those negative exponents, again, the procedure is not going to be really any different. We just take a little bit different approach to it. So if we look here, we have this 2.50883 times 10 to the negative 3rd. So we take this 2.50883 times 10 to the negative 3rd. And in this case, because I'm dealing with a small number, I'm now going to place some zeros in front of here's the original decimal place. I'm going to place a couple zeros in front of my 2. The bigger the negative power, the more zeros I'm going to add so that I have the spaces to do so. I need to move my decimal place 3 spots now. So here's where it's starting, right? And I'm going to move it 1, 2, 3 spots, and that's where it's going to end up. So now I can clean this up a little bit, and I have 0.002508883. All right, so notice with my my decimal place was right here, and I moved it 3 spots so that I could, so my decimal placers are here. I moved it 3 spots to remove that power of 10 and show the standard notation value. One more example of converting scientific notation to standard notation, that should read standard notation there, is we're going to take this, and again, we write our number. Here's where our decimal is to begin with. I'm going to start adding a few extra zeros. I'm not quite sure how many I need, but I added 4 to start with. And I'm going to move my decimal place 6 spots in this case. So it's 1, 2, 3, 4, 5, 6. And this is where my new decimal place is going to be. Here's where it was. So if you look at that, I have 7, 5, 8, 3, 0, 0, and oh, I missed an 8 in there. 7588300, which is 7,588,300 in standard notation. 2 more quick examples. Here is one with a positive power of 10 and one with a negative power of 10. So we have 5.651 times 10 to the 4th. Again, this is a big number because I have a positive power of 10. So I am going to place my zeros at the end, and I'm just going to add a few here. Here's where my decimal place is. Think about how many spaces I need to move it. 1, 2, 3, 4. Here's where I need it to be. So in this case is 5.651 times 10 to the 4 is going to be 5610. In this case, we've got a small value, a small number. We've got a very small number, less than 1. So since our number is less than 1, I'm going to place the zeros in front of my 4. Let's add 6 of them since the power is to the negative 6. 4, 3, 2, 1. Here's where my decimal place is right now. Since I need to move it 6 spaces, this is a small number, I'm going to make this 4 look small. 1, 2, 3, 4, 5, 6. Ooh, just enough. Okay, so it's going to go there. So I have 0.0000004, 3, 2, 1. Did I get enough zeros? Yep. So again, our really small number, this scientific notation is obviously much easier to understand that it is a small number, but a lot of times when we need to understand the power of it, we convert that to standard notation.